I, I have started recording. Time is quite limited, so I'll start. Today, my class will be finished, okay? By around 5:45, only 90 minutes. After that, maybe you have some instruction from Professor Matsuki. She will explain something. I heard that in around 30 minutes, okay? So my class will be finished in 90 minutes. I have received several or many questions from you. Sorry, no time to answer all of them. So I'll pick up only several questions or opinions from your side. I will utilize them for today's discussion. はい。ちょっと待ってね。I will share the screen. ノックさんね。ちょっと I'll assign Mr. Nock as co-host so that other students can join. Delayed students can join. But please manage.
はい。
はい。うん。これは、from カンヨキャオさん from Myanmar。はい。ね。Yes. Here. There's also one thing that I found different from the international practices. Okay, maybe you have learned in Maika Sensei's lecture about the engineer. Okay, the role of engineer or responsibility or required performance of the engineer. Okay, very roughly speaking, generally speaking. Japanese construction system is a bit or a lot different from international system. Okay, so that's very important point. In normal construction projects, independent engineer between the contractor and the owner doesn't exist in Japan. Okay, so that's very big difference. So this is very important point. はい。で、ちょっと待って、これそのままでいいのか。はい。So, please understand in this way. Without the engineer, okay, very important role. Yamaguchi system could solve that kind of conflict. Okay, I mean, crack was well managed. Furthermore, the quality of concrete structures was drastically or remarkably improved. Okay, so that's one way. So you do not need to remember, or you do not need to remember very details, but you can learn some essences or some you can find some key findings which can be reflected or utilized in your country also. Okay, so please understand in that way. It's okay. So today I'll continue discussion, but this is very important viewpoint. はい。それから、next。ちょっとこれ、can you see? It's a bit. はい。Maybe how can we or how can they repair the harmful cracks? Okay, or how to define harmful crack? Who judges? Okay, contractor or client or joint inspection? Check sheet is shared or occupied by government, etc. Okay? Such kind of question. If I answer this question, in Yamaguchi system, everything is shared. Okay, for example, the check sheet. This one you learned last time, right? So originally, this check sheet for grasping construction condition was developed for supporting the supervisor, government supervisor. Okay, but it's shared. I explained already. Okay, so that's why it's a kind of fair system. Okay. Of course, contractors can also utilize the check sheet for their own preparation, okay, for good concreting work. I explained already. Maybe it's clear. Harmful crack or how to repair. Well, maybe if I have time, I'll explain. Finally, this one. Last sentence by whom? Su Myat Mon-san. Sorry, he or she would like to know to investigate cover-crete quality, surface layer, cover concrete quality by what kind of test? Okay. Oh, this is also a nice question. I'll explain or I try to answer in today's lecture. So, can I go ahead? Do you have any question? I have not answered all the questions, but so far, nothing. Can I go ahead? First of all, I have not shared this paper, but this is the draft for one international conference. I'll share this paper in LMS later. Please utilize for your study and for your review or etc. The title, how can we achieve durability of concrete structures in very severe environment? Okay, so maybe you remember this picture, settlement crack, or this one. Last time I explained re-deterioration of an abutment, okay? After repairing, okay? So, so we want to avoid this kind of severe deterioration, right? Here, related to the final question, okay? How can we evaluate the quality of cover concrete, okay? So, of course, the contractors will try their best to do good concreting work, okay? Utilizing, for example, a check sheet, okay? After that, anyway, construction may not be perfect. So some kind of evaluation is or are necessary, okay? So the final question was related to this one, this evaluation, okay? This one, this check sheet was explained last time. So if you're interested, you can review, okay? This one, table 2, evaluation of cover concrete. Okay, so I will try to explain this one. Okay, so very roughly speaking, this one, this is a kind of PDCA system, plan, do, check, act, to achieve good quality concrete structures. Of course, this quality, improving my efforts will contribute to mitigate cracking also. Okay, you learned last time, right? Good concreting work can, I can say, eliminate some kinds of cracks. Okay. If you forget that story, Mama, it's okay. Up to you, up to your understanding level. Right. So here again, due to this PDCA positive cycle, okay, quality of concrete will be improved. Okay, I will show you the example. Right. This one. The title of this figure, improvement of quality of cover concrete. It's called cover concrete due to PDCA system. So before the starting of improvement, you can find some kind of defects or poor quality zone on the surface of concrete structures. But if the contractors follow the PDCA system proposed by us, you can observe, you can find very beautiful surface concrete, right? So, but this kind of very simple system can be utilized in your country also. Up to you. I have spread this kind of system to whole Japan. Okay. Okay, so far, any question?
Thank you, Sensei.
はい、ちょっと待ってください。I cannot hear you well. ちょっと待って。はい。Hello? Go ahead. あれ I cannot hear you.
Hi, thank you, Sensei.
はい。not question. Any question? Nothing? Okay. はい。じゃあ、okay, I'll explain this one. Okay, this is quite useful. It's called a visual evaluation method. Okay, here only VEM is used for the title of this table, but in this paper, it's called visual evaluation method. Okay, so using your naked eyes, okay, you can evaluate. So no special device or no special expensive devices are necessary. Okay. Right. So what's this? It's a kind of grading system. So 4 points is the maximum point. So 100%. So in this system proposed by us, 4 grades are provided, okay, for evaluation. 4 points, 3 points, 2 points, 1 point. Several kinds of defects. In this table is for normal, general concrete structures. Okay, so in this table, 5 kinds of defects are included. Okay. First one, settlement crack. Okay, you remember. The second one is very simple. It's surface air bubble. Okay. Well, for example, due to poor compaction. The number 3, chord joint. Okay. In the worst case, chord joint will become cracking. Okay. I hope you remember the very severe deterioration in underground metropolitan highway structure. Okay. Number 4, leakage of paste from the joints of the form. This is one of the examples. Okay. Right. So if you do not know so much about construction techniques or practices, okay, please try your best to follow my explanation. Number 5, sun streaking. This kind of thing. Okay. So this is related to bleeding water going up along the form surface. Okay. Right. One of the biggest characteristics, advantages of this method, VEM, visual evaluation method, is that the defects are categorized, okay, in this sheet into 5 kinds. Okay, this is very important. Because if you do not categorize or separate into each defect, you cannot evaluate. Okay, maybe you can find many ugly concrete surface anywhere outside your campus. If you are living in Japan, after leaving your building or laboratory, until you reach your home, you can find many concrete walls, or please observe as you like. Okay, these kind of defects are mixed. Okay, it's a kind of art. Okay, sometimes. Okay, or very dirty. Okay, but you cannot evaluate. So by separating or by categorizing into each defect, your eyes will start to function. Okay. All right. Okay. Then, if you know concrete engineering to some extent, or if you can communicate with the professional workers or engineers, okay, you can know the cause of these defects. Okay, what was wrong? Okay, there must be some inappropriate procedure during construction. Otherwise, these kind of defects will never happen. Okay, never appear. Okay, these air bubbles or these chord joints. Okay, this one is not flat, right? This is not horizontal. So I can easily imagine what kind of poor construction concreting work was done. Okay, for example, leakage of cement base, etc. Right? Then, what should you do if you are a responsible engineer? Okay, criticizing these defects? Okay, no. If I were the responsible engineer, I would propose the contractor to improve concreting work for their next trial, okay? Next construction, next lift. Okay? Okay, so this was the PDCA cycle. Okay, so maybe fundamental, essential points for concreting construction, concreting work must be summarized, must be included in the check sheet, right? There must be something wrong if the you evaluate, for example, your concrete as grade 2. For example, in terms of settlement crack, you should improve the construction methods, okay? Or some cases, maybe concrete property, fresh concrete property was wrong, was not good. So in that case, you should try to improve concrete properties, okay? That's the essential point. If you are want to learn more, please study this paper, okay, by yourself. That's the end of this explanation about VM. Any question?
Yes, Sensei.
Yes.
From me.
ちょっと待って。はい。Okay.
Yes, Sensei. I cannot. Sorry. I cannot see the grade for micro cracking. Is there any evaluation for the condition of micro cracking?
Micro cracking.
Yes.
Okay. So your question is that micro cracking is not included in this table?
Yeah, I cannot see.
Okay, I see.
Yes, Sensei.
Okay. My explanation was that, I explained, my explanation about VEM, visual evaluation method, was like this. This is a kind of, this sheet is for general or normal structures, okay? So in some structures, as you pointed out, for example, in Japan, in very cold regions like Hokkaido or Tohoku regions, micro cracking can easily happen, or micro cracking of the cover concrete, surface concrete, has very serious adverse effects on durability. Okay, concrete will be deteriorated due to freezing and thawing, for example. Okay, so for such kind of structures, micro cracking can be included in the evaluation item. So you can add another viewpoint to this very general sheet. Okay. So if we apply this kind of method to cold region in Japan, we improve this sheet. Okay. So this is not a 100% fixed method. So I just explained the general philosophy of this sheet. Is it okay?
It's okay, Sensei.
Right.
はい、ありがとうございます。
All right. Any other question? But if you really want to use this sheet, you need some training. You can easily imagine that the person A will evaluate some defects as 0.3. The person B might evaluate that defect as 0.2. Okay, but such kind of difference or discrepancy may happen, right? So after you go back to your country, then if you want to try this method, you can contact me. I'm the real specialist. Okay. Right. Can I go ahead? I'll stop using this Word file. Later, I'll share.
Sensei, I have a question.
Yes.
That is, in the massive infrastructure like the high abutment or a very big column, is there any type of vibrating method rather than the internet vibrators? Because in my experiences, when we are concreting columns or the structures that have the higher depth, we cannot easily, the vibrator cannot easily reach to the bottom when we completely set up the formworks. At that time, we have to open some some part of the formwork, in order the vibrators can reach, in order we can completely vibrate to the end, the bottom structures. I think that's why some cracking problems and the leakage from the formworks can be affected to the methods of using vibrators and placing, I think.
Sorry, I'm not sure whether I could 100% catch your question or not, but for example, the height of one lift should be limited, okay? For example, if the height of one lift, for example, is 50 meter, 50 meter, it's quite difficult to do vibrating, right? Generally speaking, such kind of high lift, high height, is not accepted, cannot be accepted, okay? So we should limit the height properly so that the proper compaction using vibrator can be conducted, okay? Or some other kinds of vibration, for example, using foam. Do you know the foam vibration from outside?
Okay? I mean, external vibrators.
Not internal vibrator, outside vibrator.
External vibrator, yes, yes.
External one, yes. That can be utilized, for example. Or if it's quite difficult to do compaction, for example, not only the height, but the very heavily reinforced structures.
Highly reinforced infrastructure.
Then, for example, self-compacting concrete can be adopted, okay? So there are many ways for achieving good quality, okay?
はい、先生、thank you very much.
はいはい。はい。いいですか？
はい、先生、わかりました。
はい。じゃあ、I'll finish this Word file. はい。ちょっとこれもすいません。もうやめます。で、I'll go back to PowerPoint file, which you already downloaded last time. I'll start. This is management, not concrete engineering technical lecture. This is one part of construction management lecture, so I'll focus on management viewpoint. Okay. I hope you remember the contents which I provided last time, but one very important question from your side, from students, was that maybe, okay, this is okay. Why, sorry, sorry again. This system, which I explained, was developed in very local, small government, Yamaguchi Prefecture. Okay, I'm trying to prevail or apply this system, or sometimes, of course, I need to improve. We need to improve to other local governments or to central government. Okay, one of the very important questions from your side was that why is it so difficult to spread this system? Okay, maybe you remember that question. So I'm not sure I gave you this answer or not last time, but because design was not appropriate. Okay? Design, not only the construction, good concreting work, but for some cracks, design was wrong. Okay? It means that it was the fault of the owner, okay? Owner side. Do you understand? For example, the reinforcement ratio, amount of reinforcing bars was not sufficient. However hard, however good concreting work contractors do, such kind of crack cannot be mitigated, controlled. Okay? It means that design was wrong. So maybe some of you can easily understand that they don't want, they mean that owners or government do not admit their own fault. Maybe you remember that the crack is very complicated phenomenon. Okay, anybody can say anything. Okay, so that's one of the very important reasons for this slow progress of this application of the system to whole Japan. Is it clear? I hope it was clear to you. 大丈夫？はい。OK? はい。で、if I explain from different viewpoint, so if you improve design, if you improve designing method, design details, what will happen? Cost will be increased. Okay? Cost will be increased. So, especially in Japan, owner side do not like the cost increase. Maybe clear evidence is required. Clear evidence is needed. Okay. Right. So, implementing this kind of good system into practice is not so easy. Right? I want to add one similar information. Okay. You know Professor Maika, right? Do you know Professor Okamura? 知ってますか? If you do not know him, Professor Okamura is the teacher of Maika sensei. And Professor Okamura is the teacher for me also, the former JSC president. Okay. The last night at 9 p.m., I am a morning type person, so I was quite sleepy, but I joined one monthly seminar, online seminar. The members are Professor Okamura, Professor Maekawa, and my seniors, and me, only 4 or 5. Okay, we discuss many things every month. Okay, the last night, Professor Okamura said one thing, or sent one message to us. Okay, do you know the catastrophic failure, shear failure in Kobe, of concrete structures in Kobe earthquake? Do you know? Have you learned?
Yes.
Yes.
Okay. In 1995, in January, okay, many concrete structures, especially bridge piers, okay, failed or collapsed 100% due to shear failure. In the newspapers at that time, due to poor construction or gas pressure welding was not appropriate. It is so such kind of reports, okay? Articles or have been reported in a newspaper. Okay, but the real reason was bad design. Okay, so government or academic society, including JSC, it was quite difficult for them to admit the wrong design, okay? Because it will be, or it is, or it is their fault, okay? Do you understand? The Professor Okamura, Professor Okamura pointed out that design was wrong. Okay. Please remember the name of another big professor. Okay. He is the Professor Emeritus of YNU. Okay. You should remember his name. Professor Ikeda. Okay. Ikeda. I-K-E-D-A. Professor Shoji Ikeda. He was the professor in concrete laboratory, okay, until 2002. Okay. He strongly proposed to change the design system. It's so I not explain details, but it's related to shear failure. Okay. Allowable maximum shear stress, okay, should be reduced. Okay? But he reduced by around 40%, okay, to safer side. Okay? All the big professors did not agree, okay, disagreed to his proposal. Okay? So that's the nature of human beings. Okay? Please understand. Okay? So many persons will not how do I say? I don't want to say that lie, but only a very limited number of persons, or only a very few persons, professional engineers or professional researchers, how do I say? Continue to say the truth. Okay, right. So, I am an academic person, so I'll never tell a lie. Okay, or if I am wrong, I'll after I learn the truth, I'll change. Okay, my opinion. Okay. Of course, business and academicism are different, but I am an academic person, so I will never tell a lie. So even for global warming or carbon zero emission etc., I will never tell a lie. I can see many, many lies in the business world. I hate it. So, right. So now you have felt something about the difficulty for changing the system, or especially changing design. Okay, it's quite difficult. Right? Any question? Another serious design problem was slab, RC slab deterioration. Okay. Maybe you will learn somewhere, maybe in Maekawa Sensei's class or Fujiyama Sensei's class or in this construction management class, I don't know. Okay, but very severe deterioration of RC slabs, okay, due to fatigue loading, okay, have become apparent in recent Japan. Okay, so huge maintenance cost or replacing cost is necessary. Okay, that's also goes from by inappropriate design. Okay. はい。いいですか? Can I go ahead? はい。では、そうですね。はい。How did they improve design? Okay. So, thermal cracking. Okay. Thermal cracking. You learned the mechanism last time. Okay. Briefly. So it's also called initial cracking, initial stage cracking. It's not the official name, sorry. But cracking during construction, okay? But it's clear, right? So such kind of cracking, thermal cracking, etc., is, well, of course, is also a very serious problem, but it's quite different from shear failure or RC slabs deterioration, okay? Thermal cracking will not disturb the structural performance soon, but however, we should not say that is a trivial, less important problem. We should not say like that, okay? As you learned already, crack can happen anywhere or in any structure. It can be a cause for severe conflict, okay, in terms of construction management. In that sense, I recognize this problem as also serious one, okay? Different kind of seriousness, okay? That's my understanding. Anyway, how the Yamaguchi system, how did they improve designing? Okay, I'll go into that story. Okay, hi. Here you can find the keyword construction data, concrete construction data. Okay, the data is accumulated. Okay, in the database. Okay, so I will show you the format of the construction data in this system. Okay, can you see this one? I hope I'll use slideshow mode. Totally 1, 2, 3 slides. Okay. So this is the format of concrete construction data for Yamaguchi system. Okay. In the first page, the structural shape or the height of the lift. In this case, in this sheet, this hatched one, gray portion was the target lift. Okay. So in the future, near future, the next lift will be constructed. So different data, different sheets will be prepared, provided for the next lift. Okay. Target. The very general design data are also included. Reinforcement ratio here. Concrete information is summarized in the second sheet. Temperature or date. Something like that. Okay. Sorry. In the first sheet, name of site, contractor, or structural dimensions, or if they adopt some crack control measures, they are also recorded. Okay. In second sheet, concrete mix proportion, initial concrete temperature or environment, weather, etc. are recorded. Okay. In some structures, they measure the temperature of concrete using thermometer embedded in the structure. Okay. If they measure concrete temperature, those are also recorded. Okay. Right. Not only the concrete temperature, but also the environmental ambient temperatures are also recorded. Okay. In sheet 5, actual cracking situations, conditions are recorded. Okay. in this lift, from the front side, maybe 2 red cracks are recorded. The blue one was very small, minor cracks, so smaller than the criteria, so it was not recorded. From the back side, 3 or 4 cracks are recorded. Crack widths are also recorded. Okay, in sheet 6, measurement results of cracking recorded. This is the typical format for construction data for this system. Okay. Then I'll go back to this system. So such kind of construction data, concrete construction data, is accumulated in their own database. Okay. Now totally maybe 500 or 1,000 or more data has been accumulated. Okay. The very important point is that almost all the construction of those lifts are based on Yamaguchi system. So, but I can say, or we can say that good construction, good concreting work. Okay. If the effects of poor construction is included, this database will become garbage. Okay. Do you understand? So cracks due to poor construction can be included. Then we cannot analyze later. Okay? So good concreting work and accumulating construction data in database. Those two are the points for starting management. So far clear? Oh, maybe. I'll go ahead. Then what can you do? In the design stage, you can refer database. Okay. If you construct same kind of shape, same kind of concrete structures in same season, for example, you can refer the similar structure data. If you find a very large crack, maybe you can modify design, for example. Okay? Then again, construction. Then you can evaluate the result. Okay? So this kind of loop, PDCA system, another kind of PDCA system, has been established by their efforts. They can also made their own guideline. So here it's written as manual, but I don't like the term manual. Guideline is much better. Okay, manual means you should follow 100%, right? I don't like such kind of how do I say? Robot style, not human being. Robot style, just I don't like such kind of manual. Okay, so guideline means it will guide you in proper way. Okay, right. So now Yamaguchi Prefecture has its own guideline. We are also involved in the revising process. Also, I mean improving the guideline. Honestly, every year they do minor revision. Okay. So now in the luckily it's in Japanese, but in the website of Yamaguchi Prefecture, you can find the 2021 version of this guideline. Okay. Hi. Hi. That's the explanation of this slide. Okay. Let me add one more explanation. So if you improve the design, for example, increasing the reinforcement ratio, the cost will also be increased, right? The local government, Yamaguchi Prefecture, can pay that additional cost, okay? Because they have clear evidence, okay? Right. So in such way, a kind of good management has been formed or has been, I guess, established, then still it's being brushed or improved. Okay. That's a general explanation of this management system. Hi. Any question?
Question, please.
Hi.
In this system,
Hi.
the database is the accumulation of good database is very important.
Important, yes.
So, is there anyone or any organization who is determining the good construction data only and reject the bad construction data? Is there anyone doing that?
I see. Yes. In my understanding, we should try our best to achieve good construction in every site, in each site. Okay. I mean, we should try our best to eliminate poor construction. Then all the data will become valuable data, right? So that's our basic attitude. Okay. So to do that, for example, each supervisor should know the importance of this system, and each supervisor should understand the real meaning of the check sheet, for example. To do that, education or a seminar or continuous such kind of effort, education is also very important. Okay, otherwise they forget the purposes very easily. Okay, it will become the mere just check sheet, just okay or not. So such kind of soft management is also implemented. Okay. Or yes, another example for that soft management is that every year at annual workshop, annual seminar is held. Okay, around 400 or 500 engineers or workers or government engineers, so totally in 400 or 500 people will join that seminar. For example, almost every time I am invited, I'll explain the latest invention, or I explain the importance of this kind of management, etc. The good contractors which showed very high performance or good practice in his site, he or she or they will also make presentation to share the knowledge, for example. Okay, they're not only contractors, but local government engineers will also make presentation. Okay, ready mixed concrete supplier will also make presentation. So everyone has his or her own role. Okay.
Everyone is trying their best.
Oh yes, yes.
Yes.
It was clear. But even when we do those efforts, of course, some data, I mean, including poor construction effect, might be included. But if it's 1%, 2%, 3%, maybe, it will work. Okay. But 50% are affected by poor construction, the database will become garbage. Okay. Right. Clear? Clear?
Thank you very much. Yes.
Hi. Any other question?大丈夫ですか？はい。じゃあ、これ、one example. To me, it was very shocking shocking example, but here you can find the border. Okay, actually this side, deteriorated side, it's quite long box carbide. Okay, for almost all the parts, the same kind of deterioration. Okay, very strange, severe cracking or severe corrosion or spalling of concrete, etc. Okay, this short portion constructed in 2014 at only 3 meters or something. This long carbide was extended, okay, to increase the number of lanes above this carbide. Actually, above this carbide, highway are used for highway. Okay, that's why they wanted to increase the number of lanes. Okay, you can find very clear difference, right? Of course, this is not only due to construction. Of course, designing was wrong. Material choice was also wrong. Okay, but combining all those factors, by combining all those factors, this kind of severe deterioration can happen. Okay, so which do you prefer? So I, of course, strongly prefer this long life, durable structures, which can save our future expenses or etc. Okay? This will truly contribute to save our future energy or future consumption of resources, etc. Okay? So I like this kind of direction. Okay, different from carbon zero emission, etc. Can I go ahead? We have 30 minutes more, so I will stop my lecture when time comes. Okay. This is one example for improving designing. Just one example, but utilizing the database. Okay. So what's this? Each plot, one plot means one structure, one lift, okay, in the database. For example, in this graph, vertical axis is maximum crack width, okay? I hope you remember that the threshold criteria to judge whether it's harmful crack or not in Yamaguchi system was 0.15 millimeter, okay? Horizontal axis is reinforcement ratio. Difficult for you to see, but these red dots and white dots, I mean perpendicular to this sheet, these are the reinforcement effective to control cracks. For some of you, maybe it's not clear, so I will use the whiteboard. Okay. Can you see the whiteboard? Whiteboard. Now I'm.
Yes,
yes,
it's clear.
I am in.
Yes, it's going.
Ikigaya conference center. From. I'm talking about this. This reinforcement. Okay. 大丈夫かな? はい。In this direction, from front view, like that. Okay. If you remember my explanation last time, this is footing. This is vertical wall. if crack happens, must something. Okay. So by arranging this reinforcement, crack widths will be controlled. Okay. If you increase the number of reinforcements, crack widths can be controlled. Okay. I'm talking about this kind of reinforcement. はい。で、これですね。This is very simple figure for simple explanation. So, あれはい。はい。horizontal axis is reinforcement ratio. Okay. So many kinds of data are included in the same figure. So, but very roughly speaking, if you increase the reinforcement ratio, maximum crack widths will be decreased, right? But you have to take care about the weather, or I mean season, climate. In summer season, risk of thermal cracking will be increased. So I'm not sure in this figure, such kind of care deliberation was done. For example, taking care about the climate or the size of the structure. I'm not sure. But anyway, very roughly speaking, increasing reinforcement ratio seems effective for controlling maximum crack widths. Okay. Hi. So based on this kind of investigation, they can decide the reinforcement ratio. Very roughly speaking, in the original design, without any consideration, the reinforcement ratio is around 0.1% or 0.05%, very small. Okay, minimum reinforcement ratio. Okay, that's why in some structures, very huge crack widths can be observed. I was saying that this was wrong design or inappropriate design. Okay. Contractors cannot control crack widths, okay? Only by good concrete work. Okay. If I start explaining the details, and it will be complicated. So anyway, this is one of the examples for crack control design. Okay. Hi. Several methods to increase reinforcement. Type A, type B. There are details. So. はい、ちょっとこれも I'll skip. It will be interesting, but I'll skip. はい、so far, okay? Any question? I'll go back. はい。
Sensei, I do have one question. Hi. Yeah, my question is like, since like we increase the reinforcement ratio, yes. So further, is there any limit? Like, you know, is the database have any limits that what percentage that the reinforcement ratio can be increased? Because from what I know is that if you increase a lot, then there would not gonna be enough concrete to really cover that.
I see. Okay, so yes, you're right. Now you can see the typical section of abutment. Here, footing. Here, 2 lifts of vertical wall, and finally, parapet wall. Okay. For example, for this kind of vertical walls, okay, standard value for reinforcement in Yamaguchi system is 0.3%. Okay. So it is recommended from the analysis of database. Okay, but for example, sorry. On the other hand, for the parapet, the recommended value is around 0.5%. So it's written in the guideline. So it's not the upper limit, but it's a kind of standard value. Okay. So if the contractors or if the designers judge that the risk is much higher, they can increase. Okay. Of course, the cost will also be increased. はい。
はい、先生、わかりました。はい。
But please understand that the reinforcement ratio, increasing reinforcement ratio is not the only method. Okay, I have skipped, for example, expansive additive method or many other methods. Okay, I'm just explaining in a simple way. Okay. はい。
はい、先生。はいはいはい。わかりました。はい。
はい。
ありがとうございます。
Any other question? 大丈夫ですか？はい。じゃあ、ちょっと待ってね。I'll skip this part. で、this part will also be interesting, but due to time limitation, I'll skip this part. This is the cover page, first page slide of final defense presentation by Dr. Rasul from Pakistan in 2019. Okay? I was the supervisor of this research. What's the title? Prediction of maximum thermal crack width of RC abutment. Well, now you are familiar with these keywords, right? And investigation on inflation factors using AI, artificial neural network. Right. So I will not go into detail, but using the database, combining the database, reliable database and AI, intelligence technology, we can predict the maximum thermal crack. Okay? Of course, this is not implemented in Yamaguchi system, but construction data can be utilized for many purposes. Okay, sorry, I'll skip this one. But artificial neural network. すいません、I will skip. それから、after Dr. Rasul, Mr. Adnan, maybe he is joining in this class. This is the cover slide, first page slide of his master final presentation. So still we are trying to improve the system, okay? Utilizing many methods. はい、ちょっとこれすいません。はい。で、we have 20 minutes more. Finally, I'll briefly explain the Tohoku story. Okay. Same kind of story as in Yamaguchi system, but the targets are different. Okay. Today, at the beginning of this lecture class, okay, construction management system in Japan is a bit or quite different from the international standards. Okay, maybe I guess you have learned that difference in Maika Sensei's lecture also. Okay, but from very excellent or sophisticated activities or very essential activities. Essential activities. Of course, you can learn some essences, okay, which can be utilized for different situations or opportunities, okay. Hi, so Tohoku problem, I'll explain briefly, but Tohoku problem was another kind of problem. But our philosophy, basic philosophy was the same, okay? はい。で、maybe you know a very severe disaster by great earthquake and also by big tsunami nearly 11 years ago. Right? You can find me. This is the washed away girder, okay? Precious concrete girder. Right. In Tohoku region, Tohoku is here. Okay? Which was severely damaged by the Tohoku earthquake and tsunami 11 years ago. One very big national project, government project was started for supporting or restoring this region. Highway construction. Okay, maybe you know the shape of Japanese land. We need to construct many bridges or channels due to the shape of a land. Okay, it's quite different from the land shape of, for example, France or UK, etc. I was living in France for 1 year. I travel a lot to see very famous structures, etc. Sometimes I could hardly find tunnel due to its flat land shape. Okay? But have you tried Shinkansen or have you tried highway in Japan? More very often or too often you can find tunnel structures or bridges. Okay, but that's not disadvantage. But due to that limited condition or the technology of construction technology in Japan was developed a lot. Okay. はい。で、はい。Second, that's why so many number of concrete structures were constructed in extremely cold, severe environment. Okay, you know the icing agent, okay, to control the freezing of the surface of the pavement. Okay, hi. That's why we tried to install our management system to achieve very durable, long life structures. Okay. Right. The Tohoku region severe environment was quite different from the environment in Tokyo or Yokohama. Okay. So very, very severe deterioration, mainly due to de-icing agent. But if you do not know it, please search, investigate by yourself. Okay. De-icing agent and cold environment, freezing and thawing. Okay. はい。で、sorry, here is written 200, but more than, nearly 300 bridges, big bridges, and more than 100 channels were constructed. Actually, this project has been almost finished. So it's almost completed. So now you can enjoy it comfortable driving using our highway. Please enjoy comfortable driving. Okay? はい。で、that's the background. Okay? はい。で、はい。はい。ちょっと、I will start from this slide. Okay? ちょっと again すみません。ちょっともう一回ごめんなさい。again, I'll explain very simply, okay, and clearly. So we wanted to avoid this kind of deterioration for our new structures, okay, because 200 or 300 bridges or 100 tunnels, long tunnels are constructed, okay? So if those huge number of structures show the same kind of deterioration, okay, more give up. At present, maintenance cost becomes huge, but furthermore, if we have to take care those huge number of structures, deteriorated structures, we'll give up. Okay, so our motivation is to stop this kind of deterioration for future structures. That's our motivation. That was our motivation. Okay. で、はい、only 10 minutes ですね。ちょっと待ってください。はい。で、this slide is very important, but I will not go into detail, okay? So, this slide shows multiple protection. So, these are the countermeasures to avoid these defects, which you already learned in the previous slide, okay? For example, low water to binder ratio or anti-corrosion rebar, the epoxy coated rebar, okay, etc. Please remember that improving design, by improving design, cost will also be increased. The government do not dislike cost increase, okay? That's a general nature for the owners, okay? For every structure, okay? For every structure, good construction is the basis. Good construction, by including applying self-compacting concrete. But anyway, good construction is the basis for achieving durability. Okay. Even when you adopt these countermeasures, if the construction is poor, okay, construction quality is poor, all gone. Okay. In that sense, good construction, good concreting work is the basis. Okay. But please understand that, okay? Then I'll go to next slide. That's why at the beginning, we started from Yamaguchi system. That check sheet was used. Supervisor will use, the contractors will use, okay? But it's not so easy to fully utilize this check sheet, okay? That's why I combined, this is my proposal. I combined the visual evaluation method which you learn and check sheet. Okay, then you can reflect or you can evaluate what you did, right? if something was wrong, あれ Can you hear me? 大丈夫かなはい。if something was wrong, you can improve in the next lift. Okay? Gradually, they can get accustomed to this system. You can see the example before and after. Okay? After making this kind of basis, I propose to challenge for improving the design. Okay? That was our basic strategy. はい。で、yes. I want to, this can be the final slide for today's lecture. Okay. What's this? Example 1 of life cycle cost, LCC, for reinforced concrete durable slab. Okay. Okay. This is the deterioration of reinforced concrete slab under the asphalt pavement. It's crushed already. Deterioration of RC slab where concrete was crushed into particles like soil. Okay? Very severe deterioration. Hi. This one, RC durable slab. You can find 3 cases. Okay. The first one is the conventional RC slab, which was showing very severe deterioration, as I explained already. Cost 1.0. Our proposal 1.25 or 6, including all these countermeasures. Most of the cost increase was due to anti-corrosion rebar, epoxy coated rebar. Okay? Others are not so much expensive. Anyway, around 25% cost increase. Okay? What's this? What's the final one? Real expenses due to deterioration. Okay? Orange part is demolition cost of this deteriorated slab, demolition. And they needed to conduct quick replacement. That's why construction costs became huge, utilizing prefabricated, precast, stress concrete PC panels. Okay? That's why huge construction cost, replacement cost was necessary. Totally more than 4 times of the initial cost. Okay? If you follow our proposal, 1.26, okay? But if you continue the original system, not only the initial cost, but the demolition cost and construction cost, okay? Which do you prefer? Which is environmental friendly, okay? It's clear to me. Okay? So this is also one of the evidences, okay? To promote the durability design or improving design. Okay? But it's quite difficult for the government to 100% accept this proposal. Okay? Only a few sincere engineers can understand. So still our persuading continuous efforts are necessary. Right? That's the end for my lecture. Any question? We have 4 or 5 minutes, so if you want to ask me something, you can freely ask me.
Okay, Sensei.
Hi.
compare between the durable assist slab and the prefabricated slabs, which one is like more expensive?
So sorry, prefabricated slab?
Yeah, yes. And durable assist slab.
Durable
that we are proposing, yeah.
So here you can see it, not triple, but prefabricated PC slab, much expensive. Hi.
Oh, I see.
Yes, but durable RC slab, our proposal seems cheaper, but we need huge amount of human labor. So in Japan, that is also a very difficult restriction. Okay? Difficult to find human laborers. Right. But so that's why in the future, human labor cost will be increased. So in the future, I don't know, maybe replace PC slab will also become competitive. Hi.
Thank you so much, Sensei.
Hi. Any other question? So, final message, okay? So you are learning management, okay? And you will become manager anyway in your family or in your group or in your society, okay? It means that there will be or there must be some problems to be solved or the situations to be improved, okay? So I hope you can contribute to improve such kind of difficult situation, okay? Don't keep complaining, okay? Everybody can complain, okay? But if you are a real manager, you should continue to learn, okay? Forever. And you need to collaborate with your colleagues or seniors or specialists, okay? Then problems should be managed, okay? Right. That's my last message. I'll give you my assignment in LMS soon. Sorry, at latest tomorrow. The deadline will be set 2 weeks later, for example. Please follow my instruction in the LMS assignment. Okay. はい。じゃあ、松雪先生 will hold her next lecture. So this is the end of my lecture. はい。バイバイ。さようなら。はいはい。
ありがとうございました。はい。
Thank you so much, Sensei.
先生、ありがとうございました。
ありがとうございました。
I'll upload the recorded movie. So さようなら。はい。